Recording. We are live. Okay, so we are doing lesson 1-5, solving equations using square roots and cube roots. Our warm up today, maybe, there we go. The warm up. Here we go. Janine can use up to 150 1-inch blocks to build a solid cube-shaped model. What are the dimensions of the possible models that she can build? How many blocks would Janine use for each model? And explain. Of course, we'll talk through the explanation, and we'll do some writing up here just to illustrate some things. So, I like, when I do problems like this, I like to be very methodical about it and not just kind of jump straight to like one solution or one answer, because the question isn't what's the biggest model she can build. The question is how many models can she build, right? How many possible ways can she do this? So a good way to do is just kind of build out a table or build out a list of things that she can do. So if she starts just thinking about, I can do 1 cubed, right? What is 1 cubed? It's 1. So if I do 1 cubed, I would just need 1 block. With 1 block, she can model her building, and it's a cube shape, okay? It's kind of boring, it's kind of small, it's kind of pointless, but she can do it that way. She also can think, well, maybe I'll do it 2 cubed. So that's a 2 by 2 by 2 cube, right? So how many blocks would that take?
8.
There you go, 8. And she could do 3 cubed. How many blocks does she need for that? 27, getting a little more complex, a little more difficult to build, but she could do that. What about the next one? She could do 4 cubed. That would take 64 blocks. And then what about the next one? 5 cubed is 125 blocks. She's got enough to do that. Okay, what about 6 cubed?
216.
Oh, okay, so if she tries to do 6 cubed, she's gonna run out about, 2/3 of the way through, and she's gonna be disappointed. So she doesn't have enough blocks to do that. Which by the way, the picture here, shows 5 by 5 for her model that she's built. So there you go. She could do any of these would work, but she can't go any bigger than that, right? All right. There we go. What if, and I'll just do this. Question down here at the bottom. Janine wants to build a model using 1/2-inch cubes. So she puts away the 1-inch blocks that she was playing with. She pulls out the 1/2-inch blocks now. She wants to build a model that is 4 inches by 4 inches by 4 inches. So how many 1/2-inch blocks does it take to make 4 inches, Rylan?
128.
128. If she makes it 4 inch, if we make a line of blocks, 1/2-inch blocks that are 4 inches, that I want to be 4 inches long, how many blocks would it take to make that line? 8. So if we need to do 8 cubed, 8 by 8 by 8, that's gonna be more than 128. Yeah, so we're gonna be she would need 512 blocks to make, 1/2-inch blocks to make it a 4-inch cube, right? All right. That's not a bad warm-up. Kind of gets us thinking about cube numbers. All right, as we move forward, you're gonna have to put on your thinking caps a couple of times in this lesson, because there is some new stuff. I promise it's not hard, it's just a little different. And since it's different than the way we're used to thinking about some of this stuff, it's gonna maybe feel a little confusing or hard, but just stick with me. It's gonna be okay, all right? It's just a little different than what we've been doing. Here we go. Oh, look, a video.
How can you solve equations with squares and cubes? Think about this question during the lesson. Darius is restoring a square tabletop. The area of the tabletop is 25 square feet. He wants to finish the outside edges with a piece of decorative molding. What total length of molding will Darius need? Darius begins by drawing a diagram to represent the tabletop. He needs to find the length of the sides. Use the formula A equals S squared to find each side length. Darius knows A is equal to 25, so 25 equals S squared. To solve, take the square root of both sides of the equation. Why does Darius find the square root instead of the cube root to determine the side length of the square?
That is a great question. We've been talking a lot about this through the stuff we've worked on this week, and I've tried to really point out those clue words in the problems, right? Words like area, words like square. Those tell us that we're working in 2 dimensions, that we're gonna do a square root, right? What are the words that tell us we're gonna do a cube root? Cube or cubic. And when we're talking about a 3-dimensional object, what kind of measurement are we taking? Starts with V. Volume. So if you see that word volume, we're working in 3 dimensions. And so we're gonna take a cube root in that case to solve, right? So, in this case, we've got square, we're talking about an area, which is 2 dimensions. We see the 2 in the measurement, feet squared. So all of those things are the clues to tell us what to do here, all right?
Darius needs to find the length of a square, given its area. The side length is squared, not cubed for area.
Okay, now, here, up to this point, this should feel really familiar. We've done square root, we've been doing that for last couple of lessons. And square root of 25, we've done that like 50 times already in this class, right? So what is the square root of 25? 5, all right. So that's our starting point. It's gonna be a little bit different, okay? We've gotta think about it a little bit differently than we've been thinking about it up to this point, and this activity takes us through that. And here it is. We would expect this answer to be just 5 and be done, right? But there's something else that we need to think about that we haven't thought about up to this point. When we take a square root, that's asking us what number did I multiply times itself to get 25? You with me? Does that make sense? What number did I square to get 25? And obviously 5, right? I squared 5. But what if there's another answer? Is there another answer?
Yes.
Probably, since I'm talking about it, right? Let's think about it this way. Whoops. 5 times 5 is 25. But what about negative 5 times negative 5? Oh, that's also 25, right? So we've got to think about 2 possible answers to square root problems, okay? And we're gonna have a new symbol. The new symbol is this guy right here. The plus or minus symbol is what I call it. It's also called a positive or negative. It's just a positive symbol and a negative symbol stacked on top of one another. So you can say positive 5 or negative 5, okay? Sometimes I shorten that because plus or minus 5 is shorter to say than positive or negative 5. Okay, so plus or minus 5 would work. And then they just kind of draw that out. Or we could write it this way down here at the bottom, which is, S equals 5 or S equals negative 5. So they'll write it both ways in the book, or both ways in your problem sometimes, but this way is gonna be the simple way to write it, plus or minus 5, okay? Now, we're talking about an actual tabletop. So which one of those 2 numbers do I care about? The positive 5 is the obvious answer, right?
Because the table can't be inverted.
Right, we can't have a negative 5-foot table length. That doesn't make sense. So most of the time, especially in word problems, we're gonna want the positive answer kind of as our final solution, but they're gonna make us think about both answers. Okay, because every now and then they'll throw a problem at you where you're gonna want that negative symbol. All right, here we go.
In general, an equation of the form x squared equals p, where p is a positive rational number, has two solutions. X is equal to positive or negative the square root of p. So, the equation has two solutions. Which value of s will Darius use?
All right,
Select your answer.
the equation has two solutions, but there's only one solution that makes sense. We've already talked about that. And this little generalized box down here, they always give us kind of the mathy definition or math words, using that math vocabulary to help us generalize something. So in general terms, all this is saying is we need to consider the positive and the negative square roots when we're doing the equation. Okay, so obviously we want the positive one.
The length of each side of the tabletop is 5 feet. Darius needs a total of 20 feet of decorative molding. Now you know how to solve an equation using a square root.
Now you know. All right, let's look at an example. What is the side length S of the square below? Well, we see we're used to just jumping straight to that solution, but they're gonna make us kind of think this through. So the area is 100 meters squared, so area is 100. And then they're taking the square root of S squared, so I need to take the square root of 100. And then since we're talking about a square root, it's got a positive and a negative solution. So the answer to the equation is positive or 10 or negative 10. But since we're talking about a square that can actually be measured, which one do I care about? Just the positive. So we're gonna measure it out to be a positive 10 meters, okay? Does that make sense?
Yes.
Anything like super difficult so far?
No.
I mean, you just have, it's kind of introduce something new, we have to consider the negative answer to a square root problem. Okay, so don't leave the negatives out, they're gonna make you think about it. All right, now let's shift gears a little bit and let's talk about, just one click, there we go. Let's talk about Kyle with his iguana cage here. So Kyle has a large cube-shaped terrarium for his iguana. He wants to cover the opening with a square screen. What are the dimensions S for the screen? So we need to find the side length of a cube. All right? And here's how they will work through that. Oops, I can't click that button, I forgot. I can't write on this screen in a way that'll show up on the recording, because they don't give you the tools in the program. And so anything I write is just on the board, it's not on the screen. So we'll just have to do this. I thought they worked this one out. Whoops. Oh, there it is. Next button. I want that little, There we go. All right. So write the equation, use S for the side length of the terrarium. That's the formula. Volume equals S cubed, right? So then we can plug in 343 for the volume because they tell us that up there up above. Now we take the cube root of 343. So, do we need to worry about a positive and a negative when we're doing cube roots?
No.
Why not?
Because you only wanna see the outside, I guess.
They kind of tell us there, right? A negative 7 times negative 7 times negative 7 would end up as negative 343. Negative times negative is a positive, and then times another negative would be a negative. So when we're doing cube roots, we only want one solution, that's all we get. Square roots, we get both solutions. Does that make sense? Cube roots actually end up being a little bit easier because we don't have to consider a negative possibility. You with me on that? Alright, so Each edge of the terrarium is 7 feet, so the minimum dimensions of the screen are 7 feet by 7 feet. That answers the problem. Let's move on to this example. Solves x cubed equals 64. So if we have x cubed equals 64, what do I need to do to solve that? Take the cube root of both sides. So x equals 4. That's pretty simple math, I think. Okay? Everybody good? Alright, so far we've learned about the plus and the minus, or the positive and negative square roots. We've learned that cube roots only get one symbol, they don't get both. Let's learn one more thing. What if we have numbers that are non-perfect squares? We've dealt with those before, right? And so if you put this in your calculator to do the square root of 50, what are you gonna get? Karis. Now you did cube root, do square root. Do square root of 50. 7.07, and it goes on and on and on. So what kind of number is that? It's irrational. Here's the deal, for this lesson, are you listening? For this lesson, irrational numbers are illegal. We are not accepting irrational numbers. I don't wanna see any decimals as your answer. I don't wanna see you round anything. I don't wanna see you estimate anything. Irrational numbers are not good answers for this lesson. So what they have us do, guys, it doesn't get any simpler than this. I'm gonna take the square root of 50. I got an irrational number, so I don't wanna simplify it. So I'm just gonna leave it as the positive or negative square root of 50. Leave it in radical form, leave it as a square root, okay? I don't know how else to say it. We're not writing decimals, we're not, this right here literally is the answer. This right here, okay? That's the answer. Everybody good with that? Okay. What if we're doing a cube root of a number that's not a perfect cube? We're gonna leave it in radical form. We're gonna leave it as a cube root. And so it's gonna look, we don't have to worry about the plus or minus. We're just gonna leave it as the cube root of 37. We can't simplify that, we can't round it, we're just gonna leave it. Alright? It really is that simple. I don't want you to do anything else. I don't want you to get creative with stuff. I want you to just leave it like it is. So, a cubed equals 11. I need to take the cube root of a cubed, and I need to take the cube root of 11. Is 11 a perfect cube number?
No.
Obviously not. So a equals the cube root of 11. There is nothing extra written there. There's nothing that you can leave out of that and it be okay. Alright, if I leave out the 3, it's wrong. If I leave out the symbol, it's wrong. If you add anything, if you go back, if I were to write a 3 there and make it a cubed equals that, it's wrong. This is the answer. That's the way it needs to be written. Okay? What about c squared equals 27? Well, I need to take the square root. 27 is not a perfect square, so I would write my solution as c equals positive or negative square root of 27. That whole thing is the answer. Okay, I can't leave anything out of this. Everybody good with that? Alright. I think that takes us to the end, doesn't it? Okay, so pages 37 and 38 are the assignment. We'll have some time to get started on it here, and then we will have time to work on it in class tomorrow. So let me zoom in a little bit. Let's do these fill in the blank ones. This. Let's get over here. All right. This makes it hard to write. So, what goes in these first two boxes? Z squared, that's horrible. I just zoomed in so much and then it makes it funny. Alright. Z squared and 1, so we're taking the square root of z squared equals the square root of 1. What is the square root of 1?
1.
Be more specific.
Negative 1, positive 1.
Positive or negative 1. Okay, plus or minus 1. So the solutions are negative 1 and positive 1. Square roots, you can't leave those out anymore. You've got to think of both solutions. Alright, so on this one, this cube root of a cubed and the cube root of 216. What is the cube root of 216? 6. Okay? I'm gonna do a couple more with you, then I'm gonna turn you loose. Number 10. V squared equals 47. So how do I solve it? Take the square root. So V equals what? Nolan. Not cube root. It's just a square root. And when I take the when I do a square root, what do I have to remember to include? Plus or minus square root of 47. All of that has to be a part of your answer. Don't leave any of that out. Okay? Is that good? All right, I'm going to turn you guys loose and let you work.